Hey, good morning. My name's Violet, and today I'll be teaching you about load factor. So in Comp 2521, load factor is a measure of how full a hash table is, and it can be calculated as the number of items in the hash divided by the size of the hash table. So a good analogy for load factor is cars in a parking lot. Let's see how long it takes to insert a car into this parking lot with a very low load factor. So let's just start somewhere random, and then after only one jump, more than likely we're just going to be able to insert the car, right? So that's very fast. Whereas if we look at this other parking lot, on the other hand, we just come somewhere random, we need to go all the way down here and then all the way down here in order to insert the car. And this is going to take a lot more time, and it's going to degrade the performance of our hash map. So there's a couple of solutions to really high load factor. One could be to rehash. So that's going to increase the size of the hash table or the parking lot. So there's going to be more space. So there's going to be more empty slots. So it will take less time to find one. This rehash step does take a lot of time though, and it can mean that if you hit the rehash when you're inserting, so you need to trigger the rehash, that insert can take a very long time compared to all the others, and it can make the system somewhat unreliable. Another way to do it is with bucket hashing. So that means each spot in the hash map is actually a linked list of entries and contains multiple different nodes. This doesn't have that same unexpected slowdown if you hit the expensive rehash step, but it does mean as we fill the buckets up more, we'll slow down our performance to more of a linear time thing, right? As we need to go through the linked list, which is inside the hash, in order to insert or read from the hash. So those are both ways that we can get around load factor issues, and thank you for listening. Have a good day.